All right, so I know we're getting near the end of class now. I want to do a quick recap. All right, so this is what you guys just saw. So a couple of vehicles, they tied in a race. This vehicle A started from rest and was speeding up uniformly. Vehicle B was going constant speed the entire way from start to finish. You guys had to draw a V versus T graph. So here's vehicle A started from rest. Here's vehicle B, constant velocity the entire way across. Okay? And the fact that they tied, so same place, same time at the end, means you know something like this was going on. The areas under the curves tell you how far they went, and this rectangle and this triangle are the same area. Okay? You guys had to figure out what's the acceleration of vehicle A in terms of the speed of vehicle B and the distance that they went. So there's more than one way to do it. The way I started to show you guys was, well, acceleration is the slope of this curve, which is the speed divided by this time, which is this fraction. Okay? But if you want it in terms of the distance, not the time, you have to substitute out the time. You can get that by looking at the speed of vehicle B. You can make the substitution and get that solution. Okay, there's the acceleration of the vehicle A in terms of the distance they went in vehicle B speed. Okay. Okay. There's a recap. Okay. Now, when you guys walked in, I showed you guys the honors question. If you have a 5-meter tall tower and you throw something and it lands 20 meters, you guys figured out, remember the speed ended up being 20 meters per second? You guys remember that? Right? Because it takes anything 1 second to fall 5 meters. Right? Remember, if you drop the ball side by side with us, they land same place, right? Side by side. Okay. So for it to go 20 meters in 1 second of falling, that means he had to have thrown it 20 meters per second. Okay. Right. So the challenge question I got for you guys is, can you figure out, in general, right, for any tower height in any distance, right? Let's say you were testing the blast speed of a cannon, or maybe you want to know how fast you can throw a baseball. So you try out exactly this method. You know the height of the tower you're on, you know how far you can throw it because you just see it land, you go out and measure it. Right? Can you figure out your throwing speed just in general for any H and any D? So since we got a couple minutes of class left, let me see if I can get you guys through this answer. All right. So remember what we did before. So we started with looking at that height and said, well, that's going to constrain the time. Wouldn't h be 1/2 gt squared? Isn't that true? Right? And then the t that comes out of that, well, that would tell the falling time for, right? Let me switch this around. 2h divided by g is t squared. Therefore, isn't the time always going to be the square root of 2 times the height divided by g? Right? Okay, so that's like a constraint, right? So hold on to that. Okay. Then, well, isn't the speed that you throw it, I'll call it v pitch, just how far it goes, which is this distance d, divided by the time? Speed is distance over time, isn't it? It's how far it went, how much time. Okay. Then you're going to take this expression that I just dash circled, okay, and substitute it right there. Okay. That will allow you to get an expression in terms of those original values, h and d, right? And also gravity. So I guess you could even switch planets if you were super excited about this. So that'd be d divided by square root 2h on g, and then fraction within a fraction. That works out to be, you know, flip this guy. That'd be distance multiplied by square root g on 2h. Okay, and so that's the speed of the pitch. In general, that's the answer. And just to test it, remember if you had a 5-meter tall tower and it went 20 meters, you were throwing 20 meters per second. Let's see if that works. So 20 meters it went, this is the honors question, multiplied by square root. Gravity was 10 meters per second squared, divided by 2 times the height of the tower was 5 meters, 2 times 5. Okay. This better come out to 20 meters per second. And it does, 20 meters per second. So that's a general expression. Now you can figure out your throwing speed by doing this. Okay. Hey, you guys good? Any questions? All right. So